Welcome to the 11th installment of the Arduino CAN bus series. In today's session, I'll be demonstrating a straightforward sketch for the Arduino Nano, expanding its capabilities to offer 13 inputs. These inputs can be utilized for various applications such as creating a mimic panel or interfacing with other input devices. This particular Arduino Nano will function as a producer node with a designated high priority on the bus. To achieve this, I've assigned it a CAN ID of 001. Among the Nano's pins, A6 and A7 are exclusively reserved for analog input, but for this project, we'll focus on the digital capabilities, utilizing pins set to either 1 or 0. Additionally, pins 0 and 1 serve the dual purpose of being the RX and TX for USB communication. In this setup, we'll be concentrating solely on the simple digital side of these pins. For turnout control, toggle switches are ideal. In the accompanying image, the mimic panel is employed for configuring routes and controlling various consumer nodes. Stay tuned, as I'll be sharing a forthcoming sketch specifically designed for turnout control in the next few days. This sketch will seamlessly integrate with toggle switches, offering an intuitive and efficient solution for managing turnouts in your project. Within the sketch, you'll find familiar libraries included, as seen in previous examples. On line 18, there's a global variable declared of type and signed int, named CAN ID, with a value set to 0x001. This value corresponds to the CAN ID assigned to this particular node. If you were to introduce a second node to the bus, dedicated solely to inputs, you could modify its ID to, for instance, 0x002. On line 20, a global variable of type const int is established with the name SPI_CS_pin, and its value is set to correspond to pin 10 on the Arduino Nano. Meanwhile, on line 21, a variable is configured for the interrupt, anticipating the reception of CAN messages on the bus. However, it's worth noting that for this particular sketch, where we are solely producing messages and not actively receiving them, the interrupt setup is not essential. Lines 22 to 34 are dedicated to setting up variables for the different Arduino pins designated for input use. These variables will be employed in the subsequent sections of the sketch for handling various input functionalities. On line 36, we specify the configuration for the MCP_CAN library, indicating that we are using pin 10 as the CAN select for the MCP2515 module. Lines 38 to 50 are dedicated to establishing global variables to record the previous states of the inputs. In this setup, these variables are initialized to a high state. This is intentional, as we plan to leverage the Arduino's internal weak pull-up resistors to maintain the pins at 5 volts until they are grounded to 0 volts by the toggle switch connected to them. This approach ensures a stable and predictable state for the inputs. In the void setup function, we initialize the serial communication for the serial monitor with serial.begin 115200. This is primarily utilized for debugging purposes. The subsequent 3 lines, lines 52 to 54, are included to provide information about the loaded code on the Arduino, serving as a helpful reference. This will be printed out if you plug in a USB and have the Arduino IDE open. Lines 59 to 71 are dedicated to setting up the pins designated for input, along with configuring the pull-up resistors. This section ensures proper initialization of the pins and establishes the necessary pull-up conditions for the toggle switches connected to these inputs. Line 73, the if statement, if CAN.begin, MCP_any, CAN_125 kbps, MCP_8MHC, CAN_OK, this line initiates the communication with the MCP2515 module. The parameters passed include the mode, MCP_any to auto-detect the mode, the baud rate, CAN_125 kbps, and the oscillator frequency, MCP_8MHC. If the initialization is successful, indicated by CAN_OK, it proceeds to the next steps. Line 74, if the MCP2515 initialization is successful, a message is printed to the serial monitor indicating successful initialization. line 75. The CAN controller mode is set to normal operation. This is essential for the controller to start interacting on the CAN bus, lines 76 to 79. If the initialization of the MCP2515 fails, the program enters the else block. An error message is printed to the serial monitor indicating the failure to initialize the MCP2515. In the case of an error, the program enters an infinite loop, effectively halting further execution. Line 81, this line attaches an interrupt to the specified pin, CAN_NT_pin. The interrupt is set to trigger the receive ISR function on a falling edge. While this sketch is primarily focused on producing messages, this line suggests a setup for receiving CAN messages via an interrupt, allowing for potential future expansion or modifications in functionality. Lines 167 to 177, the send state function encapsulates the process of formatting and sending a CAN message containing information about the state of a specific pin, and it provides feedback through the serial monitor for confirmation. You do not need to use all of the pins set up in the sketch, it is just an example of what you can do. Thank you for watching. I will update the GitHub wiki with more details shortly.